Hi, I would like to talk to you first about the different kinds of numbers there are. This is my friend Newton here, and he's going to help me out a little bit. The first type I would like to talk about are the counting numbers, like 1, 2, 3, and so forth. They're also called the natural numbers. Oh, I see another one of my friends coming along here. This is Euclid. He'll also help us out a little bit. Notice he has natural on the side there. I'm going to have to do a little bit of ducking. Okay. Now, let's take and add to those counting numbers 0. And that becomes what's called the whole, that's what becomes the whole numbers. So, let Euclid pass by. Now, let's take and add to the whole numbers the negative numbers, like -1, -2, -3, and so on. Here's where you have what's called the integers. So, I have my friend coming here, Euclid here. He has it spelled out for you there on the side of him. I got a duck again. Alright, now, here comes what's the Bernoulli brothers. Now, the Bernoulli brothers, that's Gene on the right and John on the left there, are dropping off a number line. And on the number line are represented the integers. We have the positive integers on the right-hand side, negative integers on the left-hand side of 0. Now, let's magnify that area, let's say between 1 and 2. Notice that there's some fractions there, like 1/2 and 2/3. And those fractions are made up of integers themselves. Whenever you have a situation like that, you have what's called the rational numbers, which include the integers. And the rational numbers are made up of fractions that are made up of integers, but you can't have a 0 as the denominator. So now let's take, for instance, 1/2 here. Now, if we divide, there's some properties of rational numbers here. If we divide 2 into 1, we'll get 0.5. There's no remainder. It stops there. That's what's called a terminating decimal. If you have that situation, you have a rational number. Let's take the case of 2/3. Now, if we take and we divide 3 into 2, we'll get 0.6. But it doesn't stop there. It goes on and on and on. Whenever you have a situation like this, where the number repeats itself, then you also have a rational number. It goes on forever here. So we can shorten that to 0.66 with a line over the top. Now, let's look at what's called the irrational numbers, like the square root of 2. Now, it's a decimal number that goes on and on and on and does not have a repeating decimal. So that's the square root of 2, an irrational number, separate from the rational numbers. Now here is pi. Now pi is 3.1415 and so on, and it doesn't repeat itself. So this too is an irrational number. Now if you take, now the rational and the irrational numbers compose what's called the real numbers. Now let's take a group that's separate from that. It's called the complex numbers. Here we have the square root of -1. This is an imaginary number. You can't take the square root of -1. Now, if you take and add to it a real number, you get what's known as the complex numbers. Okay, thank you.